Hey everyone, so this is part 2 of the Parametric Pavilion series. Today we will be going over some pretty simple, straightforward panel division, subdivision, and how to utilize some new tools within Lunchbox to really quickly subdivide your surfaces and create those panelized geometries. So from the last video that I did, I chose one of the surfaces that we created. Now this one was twisted, which I really did like, but I realized that as we continue on, it's probably not going to visually show the scripts as well as I'd like. So that isn't to say that you shouldn't use a twisted geometry, but just for educational purposes, I'm going to use the untwisted version. All right, so I have this open in the Rhino within Rhino.Inside. So I'm just going to open Grasshopper, and I already have a project open, so we can just get started. So I'm going to do really quickly, I'm going to grab this surface, the surface component, right click, set one surface, press enter, and be okay. Now, previously we have subdivided surfaces. Here, let me come on, there we go. We have subdivided surfaces using 3 components, which is a divide domain squared, which you plug in your surface into the domain, and then you create a U and a V count. So I'm probably just going to do, here, let me do a number slider between 1 and 30. Same thing, 1 and 30. Not 1 and 3. 1 and 30. So I'm going to do 10 for one, 30 for the other. That's around the proportions of the surface. 1 to 3, probably 1 to 4 really, but and then you take this divide domain and you use a isotrim component, plug the segments into the domain, plug the surface into the surface, and then you get a panelized geometry. Now it's done the opposite of what I want. I actually want 30 for the longer length, and 10 for the width. All right, so now we got a nice panelized geometry, and then from there we've used a deconstruct brep. Oh my goodness, where is this thing? There it is. To take all these panels and deconstruct them into their individual faces, edges, and vertices. And then we use the vertices to then generate our adaptive panels. Now, this is all well and good, and it's good to learn how to use, but that's kind of the base Grasshopper method. You should have downloaded Lunchbox a couple weeks ago for another tutorial, and Lunchbox has a ton of really useful tools for Grasshopper. Lunchbox has a bunch of panelization, generation tools, workflow, utility, all that good stuff. And so we're going to focus on the panels and the structure for right now, because they're pretty similar in what they do. But if you open up your Lunchbox main tab and then go to one of these groups, if you do the drop down on the panels, you can see that it allows you to generate a ton of different patterns and create panels out of those. And so what you can do is, let's say we want some diamond panels. Well, you just grab that component, and it basically asks for similar inputs. You want the surface, and then you want your U and V values. Plug those in here. And we'll hide these. Actually, sorry, we'll hide this guy. All right, so now we have a diamond structure on our surface. And then if we take the diamond panels and we plug those into the B-Rep, now we have a list of all of the faces, vertices, and edges for those diamond panels. And you can do that for any of these shapes. The only one that does not work very well, it would cause me to have to do a much longer tutorial, which maybe I'll do in the future. But so you can do quad, has the same inputs and output. You can do skewed. You can do triangular patterns, and there's several different triangular patterns that you can do. You can do staggered if you'd like. And then so all of these, if you can see, have panels outputting, and they are the singular surfaces that they create, and which you can then use to plug into this deconstruct B-Rep to get those vertices you need to then place your adaptive panel. The one that doesn't give you that, it only gives you curvature, is the hexagon. So if you are trying to do the hexagon and you're plugging in into the same process that I'm going to continue to do later on, and you're like, why isn't this working? It's because it is giving you cells, and it's giving you essentially line work and not panels. So just be aware of that. And if someone really wants to do hexagons, reach out and we'll figure out how to do that together. Maybe we'll do a separate video, but for right now, keep it pretty straightforward. Just focus on these components that are outputting geometric panels. All right. So let's keep it with diamond. Let's do quad panels right now, just because I know it'll work. And that is that's the adaptive panel that I have set up. Plug this in. Oops. Preview that. Plug this guy in. All right, that looks good. I'm going to hide this surface real quick. Okay, so now that we have these vertices, we can go back and continue with I'm going to delete these guys real quick. So we can continue on with our placing of our adaptive panel. So I am going to save the main shading device for another separate video where I'll get into the different ways that you can manipulate the parameters. But for right now, I'm going to focus on just creating the glass panel. So the way I've approached it is I've created two adaptive panels families. One is the shading device, which I'll show you in a bit, and then the other is the glass one. And the glass one, and this is what I expect, is to have obviously your glass panel, and then you have a frame around it, which is the mullion. Okay, and I've added a bunch of different parameters so that I can manipulate the size of the mullion and the frame, the thickness of the glass and the material of the glass, material of the panel. All right, and I've loaded it into my project. All right, and there it is. All right, so now I'll hide these for right now. So now we will do the same process that we did previously in the rotating tower. Is we will, let me pull up my reference real quick. All right, so we're gonna pull up our add component, component adaptive. All right, and then I'm gonna grab our specific type we need. So we'll do a category component, right click, go down to generic models, And we'll do the element type picker. And you'll see that I have a couple in here. So I want to make sure that it's the glass example. Plug that into the type. And then we're going to set up, so you could plug in these vertices into there, but like we've covered before, there are it can place it on one side of the surface or the other, depending on how the vertices are organized. So we're going to do a list reverse and put a stream filter up, which our one gate is going to be the vertices listed out in one order, and then the vertices listed out in the other order. I'm going to put a number slider from 0 to 1, plug that into the gate, and then I'm going to plug that into the points. Now, this won't be as necessary for the glass, but obviously for the shading devices, you know, if you plug in the initial list and it's all the points or all the panels are facing the wrong side of the panel or the surface, then you can use that reverse list and flip it to the other side of the surface. All right, so now we have it. If we minimize, let me turn off my shading real quick. You can see that we now have all of our glass panels on our pavilion, and all of them have the different parameters that we can manipulate. Looks pretty good. So now what we'll do, now that we have a couple different, or we have our initial panels set, I'm going to test out those different Lunchbox panels to show you the different methods that you can use and what different kinds of outputs they have. So first I'm going to close my Rhino. So we're just looking at the Revit, and then I'm going to go in, just for simplicity's sake, I'm going to lower these to a smaller number. So let's say, oh, and we are going to want to just, for shits, we're going to change all of these to even. So to do that, right click, edit, and then it gives you the option to do either even or odd numbers. And this comes into play later on when we do the structure. We can set it up so that the structural grid is a division of these panels, and so I like to keep it on even. Same thing with this guy down here. And then we'll lower this down to, let's say, 16 and 4. All right, so now that I have this reduced, you can see I'm pretty faceted, but that is what happens. All right, so we're gonna do the diamond panels first. So the diamond panels, if we turn back on the shading, maximize this again, there we go. All right, so we're gonna turn these off and disable this for right now. All right, so the diamond panels have two different outputs. One is the actual diamond panels, and one is the edge tri-panels, right? So it differentiates the two. So if you use the diamond panel approach, you're going to want to create two different types of adaptive panels for both the glass type and the shading device. One that has 4 control points for the diamond panels, and one that has 3 control points for the tri-panels. I don't have one with 3, but that's just how that breaks it up. So if you plug this guy in and then rerun it, you can see it fills in all of the 4 sided diamond panels and leaves those three sided edge panels alone, because then you have to plug the tri panels in for that. Let's see. Let's do another one. Let's do the random quads. So this one is pretty similar to the quad, but you have a random seed generator. And if you hover over this input, you'll see that it basically just asks for a value, a numeric value, that will then initiate a certain randomizer sequence. So you can do 1 to 10. And then if we go ahead and actually first I'm going to unenable, and then I'm going to unpin, delete. And on preview so I can see this. Alright, so that's pretty boring. So I'm going to increase this, see what happens, and maybe have to increase my, there we go, increase my one value so that it really starts to give some more shape. Alright. Now that I have those panels, plug it into the BREP, deconstruct BREP, re-enable that adaptive component. Now we got the randomized geometry. So depending on your surface geometry, this could be a really cool, unique pattern to explore and utilize. Of course, you do get these conditions here where the panels don't line up, so that you get these in between. So that might be, you might want to do a more regular pattern for your glass to create that really nice tight roof and wall structure, and then have the shading device be the random. But that's up to you. All right, so let's unenable this again. Delete these components. All right, let's see what else we can do. And we can put it down here. All right, and then triangular pattern. Obviously, you need those panels. I don't think, let's see. Yeah, so the only other one that really will have any unique, and then you'll have staggered. Staggered's pretty similar. So this, let's see what this T parameter needs. Assuming it's the rotation of the skew. Ooh, I kind of like that. What is it asking for? 0 to 3, I don't know. So default's at 0. Look at that. So it doesn't look like it has a clear edge resolution, unfortunately. Let's see, -3 to 3. Let's see if negative goes the other way. Yep. All right. So there's that one. And then again, and it's, let's see what the panels, let's put this back down to 10. Maybe even 6. Wait, wrong one, sorry. Oh boy. This could get funky. excited though. All right. So again, probably not the best, tightest geometry to be doing for your singular glass component of the facade, but could be kind of cool for your shading device if you could figure out how to control it a little bit better. All right. So I think that's enough. If anybody runs into another panel that they don't really understand or are having trouble getting to work, please let me know. All right, I'm going to revert back to the quad components, quad panels, because that is what is probably the most straightforward. Quad panels. All right, and then I'm going to just quickly increase the panels back up to that. Let's do 12. Preview it just to make sure that looks good. Okay, and re-enable. Make sure that you're enabling and unenabling the adaptive components, just because it can really bog down your system, and it's good to regenerate the panels as you go. Especially when we get into the parameter manipulation, the enabling and unenabling of the different components is going to be pretty crucial. So just be cognizant of that.